Joseph Matok, and I'm here to introduce you to a new technology to monitor, control, and diagnose liquid level and temperature. This technology is made of three parts. A probe that is manufactured by standard etching technology and lamination, and electronic board which include a microcontroller. In addition, we also have a firmware that together with those two parts will be able to determine temperature and liquid level. I'm demonstrating the hardware of a Unifying smart sensor for autonomous system. It's unifying because it's made of a single probe and it can detect at the same time a few functions of fluid. The probe is this one is basically the probe with a single wire and copper traces. They are all etched. And here is the productized version of this probe with the electronic board and the display that can read level and temperature. It shows also the heat removal, like how fast the heat is removed and how much is removed. In addition, one can etch on the substrate also the electrodes and coat them with conductive material. Here is two probes to detect acidity, one with a solid conductive material, one with production method that might change some pinholes and all that. And that's what the test that we have done. We have done with water, with citric acid with different concentration, as well as baking soda. And so that's what this what make it unifying. And instead of the etch electrode on this piece, we can etch the electrodes here on this one. So that's what it is. And later I will show the different fluid coolant that this probe was tested with for removing heat, how fast and how much heat is removed. These are the different coolant in which we tested the probe that you previously saw to see how good is it for heat removing, how fast and how much heat. And on this side you see the mineral coolant that was added to water. On this jar you see the 95% water, 5% mineral coolant. On this jar you see 95% water, but the coolant have changed. So you can see that if you use refractometer, you get 95% water in this jar as well as in this jar, but the heat capability, the heat removal capability in this one will be less than in the 95 and 5% new coolant. On those jars, you see synthetic coolant, again 95% water and 5% synthetic coolant, that if you put it on the refractometer, you see those ratio. And this one is a bad synthetic coolant, where you see like 10% coolant and 90% water. And in addition, eventually we're going to measure the acidity in those coolant, because when the coolant come back to the sump, it collect lubricant, and the bacteria and the water probably eat the lubricant and releases the acidic material. Now I have a test set up here that I'm going to show how I fill up this tube, and you can read the level here as well as on the digital display. And the way the level is calculated is by taking the ratio of the points there. Okay, here I'm going to move the level. I moved it to the 6 inches level, and it's reading 6 inches on the screen too. And as you can see, all this section is in the liquid, this section is in air, and based on the ratio between this relative to the junction in the liquid, I can tell where the continuous liquid level is at. Those are the functions that make it a unifying smart sensor for autonomous fluid system. Thank you.